Assalamualaikum. My name is Muhammad Adikwan. Today we want to present about the mini project Power E Electronic. Okay, this is the list name of our group members. First, Syed Muhammad Syakir bin Syed Alwi. Second, my name is third is Arif Najmi bin Akla. Okay, next I want to talk about the objective of this mini project. First, to explain the significance of using gate driver for converter circuit. Second, to understand the principal operation of boost DC-DC converter circuit. And last, to analyze the boost DC-DC converter performance and the variations of parameter. Okay, the pre-project figure 1 shows the block diagram of the gate signal generator and the DC-DC boost converter circuit. The duty cycle pulse signal are generated by comparing the sawtooth signal and the DC line with similar amplitude. This duty cycle signal are used to control the power switch. The output response of the DC-DC boost converter are depending on the switching time transition related to the duty cycle value between from 0 to 1. For our group, we use 0.7. Okay, before begin the analysis, you are required to prepare tasks as follow. Okay, the first task is analysis and discuss the operation of the circuit. The boost converter is an easy to use device. When the switch is turned on, the inductor output is connected to ground and voltage Vin is applied across it. Vin or L denotes the rate at which the inductor current grows. When the switch is turned off, the voltage across the inductor changes and equals Vout. The rate at which current flowing the inductor decays is given by Vout minus Vin divided by L.
Assalamualaikum. My name is Arif Najmi bin Akla. I will present about my part is waveform. I create this circuit using MATLAB software and use some component like VDC, inductor, current measurement, GOTO, display, software, mousepad, diode, pulse generator, resistor, capacitor, volt measurement, from and display, scope. Okay, about set in component like VDC we set 50 watt. About in inductor we set 400 micro. Is pulse generator 23 kilohertz and capacitor 100 micro. Another thing in resistor 50. Okay, what we got at current measurement is 9.425. Another thing for voltage measurement we got is 164.2. Okay, and then for checking the waveform, after run we double click at this scope. This is what we get after we run and double click scope. For the up, this is a voltage waveform and under voltage waveform is current waveform, and the bottom waveform is pulse generator waveform. And this is a current measurement what we got in the simulation. This is a minimum current and it is a maximum. Okay, to get a clear and close shape, we just need to zoom at the in on each waveform, like the bottom waveform, which is the pulse generator waveform, which the shape initially seem empty, but when we zoom, we will be able to like the waveform on the next slide. But we get it like this for voltage waveform, current waveform, and pulse generator waveform. Okay, so this is a waveform for after we zoom. Okay, thank you for me.
Assalamualaikum, my name is Syed Muhammad Shakir. I will present a calculation for this mini project. For value of frequency, my group choose 23 kilohertz and duty cycle 0.7. This list for circuit. We use resistance is 50 ohm, capacitor 100 microfarad, inductor we use 400 micro, frequency is 23 kilohertz, duty cycle is 0.7, and simulation time 2 seconds, and VDC input is 50 volt. For calculate, we calculate output voltage. V naught equals to V in per 1 minus D, and we get V naught 166.67 volt. For second, we calculate inductor current. V in equals to 1 minus D equals R, and we get 3.33 ampere. Third, we calculate inductor maximum current. V in per 1 minus D is lower, and R plus V in dt per 2L, and we get 13.012 ampere. For we calculate inductor minimum current, V in per 1 minus D R, and V in dt per 2L, and we get 9.208 ampere. Last, we calculate voltage ripple. V naught dt per RC and equals to V naught D per RCF, and last we get 1.01 volt. For assumption, first we operate in steady state. Second, capacitor is very large. Output is held constant at value V out. Third, inductor current is continuous, always positive. For wishing period is T, which close for time dt and open for time 1 minus t t. Lastly, the components are ideal.
Okay, next, table comparison, calculation, and simulation. Okay, we measure for four value. First, output voltage, inductor current, inductor maximum current, and inductor minimum current. For output voltage, for simulation we get 164.2, and for calculation we get 166.67. And inductor current, we get 9.428 for simulation, and for calculation we get 11.11. Next, for inductor maximum current, we get 10.39 for simulation, and calculation we get 13.012. And last, for inductor minimum current, we get 10.11 for simulation and 9.208 for calculation. So we can see the value of simulation and calculation just have a little bit different. Little bit different for measure value and calculation value. Okay, but for inductor current, we have do something mistake when simulation. For end the presentation, we go to conclusion. This paper describes a novel boost converter architecture that includes a voltage extension cell. Both simulation and theoretical studies show that using a boost converter with a voltage extension cell improves output while lowering voltage strength on switches and other losses. It increases the lifespan of circuit components by lowering voltage strengths. A boost converter with extension cell can help with photovoltaic power generation and other low input voltage and high output voltage gain circuit. Okay, so that's all from our group, and thank you.